Good morning. We are going to start studying functions now. So we begin by redefining what a relation is. We're actually already familiar with relations. We've been working with relations for quite a while. One you should know, x squared plus y squared equals r squared. Circle of radius r. That's a relation. Relates values of x and y. Even something as simple as y plus x equals 1 is a relation. It is a set of ordered pairs. If you look at all the ordered pairs, the set of all the first components is called the domain of your relation. The set of all the second components is your range. So domain value is also called the input values or your independent variable. Whereas the elements of the range are the output or your dependent variable. Right, typically, we'll say that elements in the domain are x, elements in the range are y. That is standard notation, but it is just notation. It is not a fixed rule. We can also say y is a function of x. Y is the independent, whereas x is the dependent, or any combination of letters, symbols, whatever. Well, a function is just a special type of relation. It's a relation in which each possible input value leads to exactly one output. In which case we'll say the output is a function of the input. So y is a function of x. And so notice that this has two rules embedded in it. First, every input value has to go to something. And specifically, it can only go to one thing. What it doesn't say is it doesn't say that two input values can't go to the same output. As long as each input only goes to one, it is a function. Input would be the domain. So if we look at something real simple, y equals x squared. Your domain would be all real numbers. But your range would be non-negative real numbers. Right? 0 to infinity. Right. However, we will typically write that still as a function from reals to reals. In which case we don't call it the range anymore, it's the codomain. Right? The range is just the values that are spit out. The codomain are all the possible values you can get. For our purposes, we're not going to really deal with codomain. That's for a more advanced study of functions. This is the standard notation for functions. It's read y is a function of x. Right? So y equals f of x. The function name is f. That's obviously our dependent variable. And the independent variable is the three common ways of looking at functions: the relation as a mapping between sets, which is the most viewed way, or as a machine. But the idea is always the same. We look at it as a mapping. Now you have two sets, A and B. What F does is it'll take from each element of A and map it to an element in B.
But what it can't do is go to two of you?
Right, so this one element can't go to two of them. But that's fine. You have two inputs going to the same output. That's fine. And so often you'll hear me say probably, like for instance, x squared. 2 gets mapped into 4. Which means that 2 squared is 4. The machine is, again, a very similar kind of thinking. You input something into the machine is the function f, and it spits something out. It produces something. So again, in terms of 2 squared, you put 2 into the squaring machine, and then 4 comes out. This is going to be extremely important in calculus. The difference quotients. If you're given a function f of x, the difference quotient of f is the value f of x plus h minus f of x all over h. Here, h is representing what's known as an incremental change in x. You may see it written also as delta x instead of h. So we say that difference between the 2 points is h, that's the incremental change. It means that the second point is x plus h. take a look at that line. The line that passes through those 2 points. That kind of line has a special name. Does anyone know what that line is called? Slope is a specific measure of a line, but I'm going to be using slope here.
I'm not sure I have the right name, but like, is it like where like you have like a lot of dots and then you just draw a straight line through like the middle of all of them? Is it that?
No, that is
You know, I'm thinking.
line of best fit.
Okay, yeah, that's what I was thinking.
Usually it's a least squares regression line in statistics. No, but this does lead into a tangent line. Tangent line is from calculus. This is the secant line. So a secant line just connects 2 points. It's a line through 2 points of a function. What's the slope of that line?
Negative.
I would agree in this case it is a negative slope, but I want a value. How do you find slope?
Oh, we're doing like taking the 2 points, like isn't it y2 minus y1 over that I know what equation it is in my head, but I can't, yeah.
Delta y over delta x. Rise over run. Value for y. I don't know. Be this point. You can't see. There. It's this point here, right? And what's the y coordinate? Well, if this it represents f of x, it'd be f of x plus h, right? What's the y coordinate of your initial point?
X.
What is it?
X.
That's the x coordinate. What's the y coordinate? Again, be f of whatever that point is, right? X coordinate of your final point.
X plus h.
Minus the x coordinate of the initial point. What's x minus x? Isn't that just the difference quotient? So difference quotient geometrically represents slope of the secant line between the 2 points. It also has a physical interpretation that we'll examine later. So a review of some notation. Interval notation and what it means. And then you have the ones where you have the two inequalities. Why is that important? Well, domain. Is an interval of values. So is range. So we need to be able to write intervals. For now, the process of finding domain, start with all real numbers, minus infinity to infinity, and then remove any restrictions. And for now, we only have two of them to worry about. What number can you not divide by?
Negative.
0. So if your function has a denominator, it cannot equal 0. We're dealing with real valued functions in this course. With that in mind, what happens when you square a number or raise it to the 4th power or 6th power?
Doubles.
It becomes the I, the imaginary number.
Take any number and raise it to an even power. What's negative 2 squared?
2. Positive 4.
What's negative 2 to the 4th power?
8. Or no, 16.
Positive 16. Negative 2 to the 6th power?
36. I'll just keep multiplying the power by 2.
Positive 64. You always get a positive number out of it. So if you go to take a square root or a 4th root, it can't be negative. Right, so the roots we call radicals. The index is, for instance, square root, the index is 2. 4th root index is 4. So if that index is even, what's under the radical must be non-negative, 0 or larger. So fix that. Given a relation, in this case y equals x squared plus 4, is this relation, does it define y as a function of x? Remember what that means. For each x value, you can only have one corresponding y value. Yeah, that's right. Pretty obvious. No matter what value you put in for x, you're going to get one value for y. So that is a yes. Y is a function of x here. X equals y squared plus 5. Well, the easiest way is to solve for y. First thing you do, subtract 5, right? Since we're solving for y, our goal is to isolate y. Square root of both sides, right? What is the square root of y squared?
Y.
What is it?
Positive y, negative y.
Mathematically, absolute value of y. Can't just be y. What if y is negative 2? Negative 2 squared is 4 squared root of 4. That is 2, which is absolute value of negative 2. That means that y is either negative square root of x minus 5 or y is positive square root of x minus 5. Which means each x value gives you 2 y values. So that's the function. If I reworded it, though, does that relation define x as a function of y?
Yes.
Now it does. So it all depends on what your independent variable and what your dependent variable is. So make sure you read the question carefully. Oh, well. Y equals square root of x minus 5. Is y a function of x? In this case it is, right? Because we're only considering the positive square roots. What about the relation of y equals 5? This is a constant function. Its graph is just the horizontal line, right? At 5. Well, that means each x value goes to only one y value, right? Just happens to be every x value goes to it. But that is not a violation of the rule. X squared minus y squared equals 36.
Yes.
Y a function of x?
Because when you just add y squared to both sides and square root on both, and then you have x equals 36 plus 1.
But that's not what we're trying to solve. We're trying to solve for y.
Oh, I meant, alright, then flip them.
If you take the square root of both sides, square root of x squared minus 36. It's just the square root of x squared minus 36. Remember, a square root does not distribute across subtraction or addition. But then we get, again, absolute value of y, square root of y squared. That means each x value is going to give you two y values, the positive and the negative. That's not a function. Now again, a simple change. Let's do instead of y squared, let's say that's x squared minus y cubed. Using similar logic from before, you're going to get x squared minus 36 is y cubed. What would you do? How would you solve for y?
Take the cube root.
What is the cube root of y cubed?
X minus 36.
Cube root of y cubed.
X to the 6.
Y.
Just y. Piecewise functions are just as they are named. They're functions that are defined in pieces. This one happens to be 3 pieces. So when we look at piecewise functions, these are the rules. These are the domains for the rules. And then you look at each row. Right. So let's start with g of -3. Which domain does that fall into? Is -3 less than or equal to -2?
Less than.
So it fits into that rule. So you plug it into that one.
Wait, so you said, wait, so it's the orange box compared to the red?
Those are the rules.
Are
Right, so that'd be like your function definition. And the red is for that domain.
Okay.
Absolute value of -3.
It's 3.
-2 times 3,
6.
-3. G of -3 is -9. G of 3 is 3 less than or equal to -2. Is 3 between -2 and 3. I agree 3 is greater than -2, but is 3 less than 3? Is 3 greater than or equal to 3? So it goes into that last one, which says it's 4.
So they should fit into a red box, right? Like you just try in every
Yeah, you
red.
figure out, okay, which domain does the value fit in? And it is possible it may not fit in any of them, in which case you say the function's undefined. G of -2. Which piece are we going to plug it into? First, second, or third? First one. -2 times 2, -4, -3, -7. What about 0? Which rule does that get plugged into? Second one. Five times 0 is just 0. Add 6, you get 6. And what about G of 4? Which rule does that go into?
They're greater than or equal to, or none.
None is undefined.
It's
You sure?
It's less.
4 is greater than 3, isn't it? Precalculus, which means 4 will be greater than or equal to 3.
Oh, shit, yeah.
So G of 4 is just 4.
I'm with you.
Piecewise functions are used a lot. Energy bill uses piecewise function. They actually look at your energy bill breakdown. One that may hit closer to home, taxes. Federal income tax is a piecewise function. You have different brackets. Of course, the tax code is so freaking convoluted. That's why you have tax professionals who have to take a course every freaking year because it changes every year.
Or you just use TurboTax, right? Like for the free.
I wouldn't. All it takes is you doing it once and then putting a number wrong, and the IRS is knocking on your door asking to audit you. No, I'll pay my $300 every year and have my guy do it. Because then he has to deal with the IRS, not me. Because I have been audited.
Really? Yeah, you gotta have.
I'm actually still in the process of fighting that.
Don't you gotta have
3
like
years later.
7 years of documents like of your taxes before that when they audit you?
But because I go to a guy, it's all stored.
He's got it.
So I don't have to worry about it. But now he's dealing with the IRS, not me. And it's been a 3-year process.
Yeah.
We're almost at the stage of going to court.
They think you're robbing.
Oh, they actually did rob my return
Really?
because they said I owed and I didn't. So they robbed my last return.
When you get it back, like if
Oh, I'll get it back with interest because I'm entitled to it. But we have to fight it. That's why I pay a guy to do it. Nope, I'm not doing that crap.
hell,
I just signed over power of attorney to him. So we're at that stage. Yeah, nope, not dealing with it. My Rusty suck a big one.
IRS is difficult to deal with too.
They're not the smartest people either.
Or you could just work for the IRS.
The IRS are not the smartest people. I would never work for.
We're worried about auditing you, and there's mass, like, there's people committing real tax fraud out there.
F of 1.99. And here's something else that's interesting about the IRS and the tax code.
This is a second.
It's actually not illegal to not pay your taxes.
Well, if there's-
It was only
there's ways
supposed to be
around it.
like a temporary.
It's illegal to not file. It's not illegal to not pay.
So I gotta do it.
So they can't throw you in jail for not paying. They can throw you in jail for not filing.
So I can file it with TurboTax and it's not.
And then not
paid.
pay.
Alright.
But the problem is IRS has unlimited power, so they'll just garnish your wages, which is actually unconstitutional and illegal. But then you have to fight it, and the IRS has unlimited resources, so they can hire an attorney for a lot longer than you can. Yeah, 1.99 definitely falls in that second one, right? What is 2 times 1.99? 3.98. Be honest. Did you use a calculator?
No.
I'm impressed. Good job. F of 0.4.
The first one.
0.4. F of 3.
This is fourth one.
Third one. Yeah, 3 times 3, 9. F of 1.
First one first.
Bonus. F of 0.
First one.
None.
None of them.
And how can 0 be less than 0?
0 is not less than 0.
It says x has to be greater than 0.
But 0 is not greater than 0 either. Notice this domain is positives. 0 is not in the domain, so there's nothing. F of 0 would be undefined.
You
So,
did the 3.001.
so I missed one. Oh, I did.
Did that do the fourth one?
Missed that one. So F of 3.001, yeah, it is the fourth one. Which is what?
12.004.
Practice finding difference quotients. This, like I said, is going to be an extremely handy skill in calculus. Remember, that is the difference quotient. There's f of x plus h minus f of x then all divided by h. Simplify the numerator. First step, distribute that -3 through, and then distribute the negative through the second grouping. Not simplified yet. Combine like terms. -3x plus 3x is 0. 8 minus 8 is 0. Left with a -3h in the numerator. Oh, well now, look, that one's easy to see. You have an h common in both the numerator and denominator. Since we're assuming h is not 0, that just becomes 1. And you're left with -3. Difference quotient here is -3. If you think about it, -3x plus 8 is a line, isn't it? Which means the secant line between any 2 points on it's going to be the exact same line. So it's going to have a slope of -3. So your difference quotient should be a constant. So that one's easy. Now we're looking at a quadratic. of x plus h minus f of x all over h. For the sake of space, I'm going to do two steps at once. I'm expanding out the quantity x plus h squared and then distributing the -4 through. Also distributing that negative through. We have 4x squared minus 4x squared, that's 0. We have 2x minus 2x, that's 0. We have 6 minus 6, that's 0. Look at what remains. And h is common. Actually, there's a negative h common. But I'm not going to factor out the negative h. I'll just factor out positive h. Negative 8x minus 4h minus 2 all over h. H over h is 1. And we are left with negative 8x minus 4h minus 2. There's our difference quotient. In calculus, you just do one more step, which would just be to pass it through a limit. Which is actually the easiest part of that.
Is it true that like calculus is like easier than pre-calc? Because like pre-calc's like just basically
Calculus is easy.
Because pre-calc's like just learning like learning the formulas, right? And then calculus is just
Well, it's not just the formulas. It's a continuation of algebra. Calculus is actually very easy. It's the algebra that's really hard. A lot of people who fail calculus don't fail it for the actual calculus. They fail it for the algebra. Yeah, algebra sucks. You're going to learn that real quick.
I'll learn that in middle school.
Algebra really sucks. That algebra was nothing. That was easy. Just wait. You have 3 pages of work and only one line of it is actually the course that you're taking. The rest of it's algebra.
I know the box method. And the diamond method.
Yeah, we don't use that.
That's what I used in high school though.
Yeah. Mathematicians laugh at Common Core. Just saying. We think it's a joke. Cubic. F of x plus h first. X plus h quantity cubed minus f of x all over h. Should have enough room. So expand out x plus h cubed.
So basically, that's what you would get if you did like x plus h times x plus
Mhm.
h. Okay, so like realistically, I don't have to do all the work.
There is a nice shortcut for expanding binomials to a power. It's really, it's actually really cool and really useful.
So that's the shortcut.
That's the binomial theorem. N choose R is the NR binomial number. That's the hardest part. But there's a nice relationship. Ever heard of Pascal's triangle? Every entry in Pascal's triangle is a binomial number.
What was the top part called again?
That's the binomial theorem. We're cubing it. Right, in this case, cubing it. So we go down to the third row of the triangle. Zero, 1, 2, 3. Those are your coefficients. 1, 3, 3, 1. One, 3, 3, 1. First term starts at the highest power. Second term starts at the lowest power, which is 0. Then you just keep subtracting a power from your first term, in this case x, with each subsequent term, right? So x cubed, x squared, x, and then x to the 0. H to the 0, h to the first, h to the second, h to the third. And then you multiply them by the coefficients. And there's your expansion.
Sometimes it's a bit easier just to get the long way. I did that in high school, and it's really easy to get confused. You make
plus y to the 10th power. Do it using the FOIL method. I'll do it using Pascal's triangle, and if I have time for lunch. Of course, anything about that x plus y to 100th, I'll just throw it into a computer. I ain't doing that by hand. Damn that. You don't have to go up that high. I think 5th power might be as high as we go. You can do foiling. I'm not going to stop you. This is just a nice shortcut. Let's see, what do we have? X cubed minus x cubed, and 2 minus 2. Notice what we're left with. We're having h in common. So I'll factor out the h, and we'll be left with what? 3x squared plus 3xh plus h squared. H over h, 1. And there's your difference quotient. Three x squared plus 3xh plus h squared. Let's have a fraction involved.
Fractions.
F of x plus h minus f of x all over h. So here we have a compound fraction, also called a complex fraction. What was the rule for simplifying compound fractions?
You can flip it on the bottom.
Times 1 over h, that's true.
Yeah, because it's a negative, whereas you can flip it to the bottom, make it positive.
That's only if it's a negative exponent. And you can have it attached by addition or subtraction. Multiply by the LCD. Both numerator and denominator by LCD. Which in this case, x plus h plus 2 times x plus 2.
Wait, so you multiply them?
Both numerator and denominator by the LCD.
By this common denominator.
Which is x plus h plus 2 times x plus 2.
Okay, yeah,
Right? Because if you multiply numerator and denominator by the same thing, That's the same as just multiplying by 1, right? And multiplying by 1 doesn't change the value. So you're allowed to do it. We have an x minus x. That's 0. 2 minus 2 is 0. So in the numerator, aren't we just left with a minus h? And you have h over h. Negative 1 over x plus h plus 2 times x plus 2. And there's our difference quotient. And it is custom to not expand out the denominator. So don't do the modified FOIL there. Just leave it like that. And one that has square roots. Domains. Remember what we do with domain. Start with all real numbers. Then remove restrictions. So typically, what I'll do is I'll look at the function and I'll go, am I going to have any restrictions to worry about? Do we have a denominator? No. Do we have a radical? We're done. So there's two ways to write domain: in set notation, which is what I just did there, all real numbers, or as interval notation. Negative infinity to positive infinity. Unless you're specified a specific way, it doesn't matter which method you use.
The first way is what?
Set.
Set notation.
It's the set notation. And that blackboard bold R just simply means the set of all real numbers. That one was easy. Do we have a denominator? I'm going to start there. Your denominator cannot equal 0. Solved the same way as if it was actual equality instead of an unequality.
You said it equal to 0?
X squared can't be 9. Means the absolute value of x can't be 3. Do we have a radical? So we're done. The domain is everything except when the absolute value of x is 3. Again, two ways to write it. Set notation. Technically, you should write that. Set of all real numbers x such that absolute value of x is not 3. However, we are implied to be dealing with only real numbers. So I'll probably wind up just doing this. Set of all x such that x cannot be, or absolute value of x cannot be 3. That is your set notation or set builder notation.
And the line next to the x, that means what is it?
That is such that. You'll see either the straight vertical line or a colon. In interval notation, the absolute value of x can't be 3. What do we take out of the interval?
3.
Just 3?
And negative 3.
We're going to remove both positive and negative 3.
So negative infinity, comma negative 3, and then the u.
Unioned
Or
with negative 3 to 3, unioned with 3 to infinity.
and u, that just means a gap, right?
Yeah, we're excluding negative 3. So union means, if you're talking about sets, the
Gap.
union of sets is everything in either set.
And like if you were to put it on a number line,
You have open holes.
you have a hole, you have a gap.
Yeah. Not really a gap, because it's just a single point.
So would I be wrong if I did negative infinity, comma negative 3, union 3, comma infinity? And
Yes.
set that?
Because you just exclude everything between negative 3 and positive 3. Right? On a number line, you'd have to draw it this way.
Okay.
Open holes, and then it's literally everything in between. Everything except for those 2 points. So that's why it's not really a gap, so to speak. It's just 2 single points being excluded. Any questions?
You said, what time do you post this live? After class?
Sometime after class, by the end of the day.
And the first homework assignment, that's going to be posted today, right? Or is it already up? Because you said Monday.
I think it's up.
So that's what I was gonna ask you, was about the response, thing. I wasn't able to even do a response. I checked earlier in class, and is that the one posted?
The what wasn't?
So you remember how first day of class you were like, oh, you have to post a response to this question, and then on the 27th you do a response to one of the classes or 2 of the classmates. I went to go check it just to see what it would be like, or how the system works, because Blackboard Ultra is new. And I wasn't even able to see anybody else's responses.
Because you have to do an initial post before anything shows up. That's how I have it set up.
Yeah, I did one. It even says that I did an initial post.
I'll double check settings and see what's going on.
I'm pretty sure I saw all of them.
You should be able to see them once you post.
Okay, it's strange.
I'll try again and see.
Big one? The big line means set.
Which one?
The big line next to that one.
It's shorthand for such that.
Such that. So like, if you were to say that whole thing, how would you say?
It's the set of all x such that the absolute value of x does not equal 3. Right, just another way of saying all real numbers except positive and negative 3. So we'll continue with domain on Wednesday, and then look at the behavior of graphs. So responses are due tonight, don't forget. First homework on WebAssign is up, due next Monday. Before class, you will have always 1 week to work on the homework, with the exception of maybe the last 1 or 2, right, because of finals. And don't forget, your project has a due date of February 12th, so start looking at that.
I'm still not in the group.
I have to get it and read it. I'm going to do that during my break today. I did update the roster, so. See you Wednesday.